Optional chaining. Optional chaining is a process for querying and calling properties, methods, and subscripts on an optional that might currently be nil. If the optional contains a value, the property, method, or subscript call succeeds. If the optional is nil, the property, method, or subscript calls returns nil. Multiple queries can be chained together, and the entire chain fails gracefully if any link in the chain is nil. So that's a kind of nice little feature. If you don't know what optionals are, you should first look at my tutorial on optionals. Optional chaining is an alternative to forced unwrapping. You specify optional chaining by placing a question mark after the optional value on which you wish to call a property, method, or subscript. If the optional is not nil, this is very similar to placing an exclamation mark after an optional value to force the unwrapping of its value. The main difference is that optional chaining fails gracefully when the optional is nil, whereas forced unwrapping triggers a runtime error when the optional is nil. To reflect the fact that the optional chaining can be called on a nil value, the result of the optional chaining call is always an optional value, even if the property, method, or subscript you are querying returns a non-optional value. You can use this optional return value to check whether the optional chaining call was successful and the returned optional contains a value, or did not succeed due to a nil value in the chain. The returned optional value is nil. Specifically, the result of an optional chaining call is of the same type as the expected return value, but wrapped in an optional. A property that normally returns an int will return an optional int when accessed through optional chaining. The next several code snippets demonstrate how optional chaining differs from forced unwrapping and enables you to check for success. First, here's two classes, person and residence. Person has a residence optional, and residence has a number of rooms which is set to 1. Residence instance has single int property called number of rooms, which is defaulted to 1. Personal has instance optional residence property. If you create a new person instance, its residence property is default initialized to nil. By virtue of being optional, in the code below, John has a residence property value of nil. Let John equals person. If you try to access the number of rooms property for the person's residence by placing an exclamation mark after residence to force the unwrapping of its value, you trigger a runtime error because there is no residence value to unwrap. Let room count equal John.residence exclamation mark dot number of rooms. This triggers a runtime error. The code above succeeds when John.residence has a non-nil value and will set room count to an int value containing the appropriate number of rooms. However, this code always triggers a runtime error when residence is nil, as illustrated above. Optional chaining provides an alternative way to access the number of rooms. To use optional chaining, use a question mark in place of the exclamation mark. If let room count equal John.residence question mark dot number of rooms, then print John's residence has room count rooms, else print unable to retrieve the number of rooms. If you remember from the optionals tutorial, if let basically unwraps it and allows us to have the actual room count instead of the optional object. So this tells Swift to chain on the optional residence property and to retrieve the number of rooms if the residence exists. Because the attempt to access the number of rooms has the potential to fail, the optional chaining attempt returns a value of type int optional or optional int. When residence is nil, as in the example above, the optional int will also be nil to reflect the fact that it was not possible to access the number of rooms. The optional int is accessed through optional binding to unwrap the integer and assign the non-optional value of the room count variable. Note that this is true even though the number of rooms is a non-optional int. The fact that it is queried through an optional chain means that the number of rooms will be an optional int instead of an int. You can assign a residence instance to John.residence so that it no longer has a nil value. So you can say John.residence equals residence, and now you don't have a nil value, you have an actual residence there. John.residence now contains an actual residence. So if you try to access the number of rooms, you will get back the default value of 1. If let room count equal John.residence question mark dot number of rooms, print John's residence has room count rooms. That prints 1 room. Now defining the model classes for optional chaining. You can use optional chaining with calls to properties, methods, and subscripts that are more than one level deep. This enables you to drill down into subproperties within complex models of interrelated types and to check whether it's possible to access properties, methods, and subscripts of those subproperties. The code snippets below define 4 model classes for use in several subsequent examples, including examples of multi-level optional chaining. These classes expand upon the person and residence models above, with adding a room and address class with associated properties, methods, and snippets. So we got our person with the residence. The residence now becomes more complex than before with rooms and number of rooms method and a subscript which can give us a given room and set the value for the room, and we can print the number of rooms, and we can also have an optional address property. Because this version of residence stores an array of room instances, the number of rooms property is implemented as a computed property, not as a stored property. The computed number of rooms property simply returns the value of the count property from the rooms array, and as a shortcut to accessing its rooms array, the version provides a read-write subscript that provides access to the room at the requested index, and the version of residence also provides a method called print number of rooms, which simply prints the number of rooms in the residence. Finally, residence defines an optional property called address with a type of address. The address class type for this property is defined below. The room class used for the room array is simple class with one property called name and an initializer to set that property to a suitable room name. So class room, let name be a string, init name string, self.name equal name. The final class in this model is called address. This class has 3 optional properties of type string. The first 2 properties, building name and building number, are alternative ways to identify a particular building as part of an address. The third property, street, is used to name the street for that address. So here we have the address class with the building name, building number, street, which are all optional strings, and then the building identifier function, which gives us a optional string back. And if we let the building number equal building number, let street equal street, return the building number street, else if building name is not equal to nil, return the building name, else return nil. The address class also provides a method called building identifier, which has a return type of string. This method checks the properties of the address and returns building name if it has a value, or building number concatenated with string if both have values, or nil, otherwise accessing properties through optional chaining. As demonstrated in the optional chaining as an alternative to forced unwrapping, you can use optional chaining to access a property on an optional value and to check if the property access is successful. So let John equal person, if let room count equal John.residence is an optional .number rooms, let John's residence has this many rooms, else unable to retrieve rooms. So because John.residence is nil, we will get the failed case. And you can also attempt to set the property value through optional chaining. Let some address equal address, some address dot building number equal 29, some address dot street equal Acacia Road, and John.residence dot address equals some address. And so in this example, since you're attempting to set the address property of a optional which is nil, it will fail and the residence will be nil. The assignment part is part of the optional chaining, which means none of the code on the right hand side of the equal sign is evaluated, saving CPU cycles. In the previous example, it's not easy to see that some address is never evaluated, and because accessing a constant doesn't have any side effects, the listing below does the same assignment, but it uses a function to create the address, and the function print function was called before returning a value, which lets you see whether the right hand side was evaluated. So func create address goes to address, print function was called, let some address equals address, So the idea here is simple. The create address function will print that the function was called in order to let us know if this optional was nil or not, because if it was nil, the create address would not be called. So now calling methods through optional chaining. You can use optional chaining to call a method on an optional value and to check whether the method call is successful. You can do this even if the method does not return a value. The print number of rooms method of the residence class prints the current value of number of rooms. Here's how the method works. Func print number of rooms. Okay, and just print it. So this method does not specify a return type. However, functions and methods with no return type have an implicit return type of void. This means that they return a value of empty or an empty tuple. If you call this method on an optional value with optional chaining, the method return type will be void. Optional, not void, because return values are always an optional type. When called through optional chaining, this enables you to use an if statement to check if it was possible to call the print number of rooms method, even though the method does not itself define a return value. Compare the return value from the print number of rooms call against nil to see if the call was successful. So if the residence.print number of rooms is not equal to nil, print it was possible to print the number of rooms, else it was not possible to print the number of rooms. The same is true if you attempt to set a property through optional chaining. The example above in accessing properties through optional chaining attempts to set an address value for John.residence even though the residence property is nil. Any attempt to set a property through optional chaining returns a value of type void, which enables you to compare against nil to see if the property was set successfully. So if John.residence.address equals some address is not nil, then you can print it was possible to set the address, else it was not possible to set the address. Okay, accessing subscripts through optional chaining, same kind of thing. Note, when you access a subscript on an optional value through optional chaining, you place a question mark before the subscripts brackets, not after. The optional chaining question mark always follows immediately after the part of the expression. That's not optional. Okay. You can use optional chaining to retrieve the value of a subscript on an optional value and to check whether the subscript call is successful. So John.residence question mark 0. So basically .name. That's the first room name. Okay. So the question mark goes before the 0 here as we try to get the name of the first room. The optional chaining question mark in the subscript John.residence. So if John.residence is set, we will get it, otherwise it will fail. And similarly, you can try to set a new value through a subscript with optional chaining as well. So you can do John.residence question mark 0 equal room name colon bathroom. Now again, if John.residence does not exist, this second part will not evaluate, the right hand side will not evaluate, and we will still have a nil for that. Now if you create and assign an actual residence to John.residence with one or more room instances in its room array, you can use the residence subscript to access the actual items in the rooms array through optional chaining. Let John's house equal residence, John's house.rooms.append room, living room, append kitchen, John.resident, John house. If let first room name equal John.resident 0.name, print first room's name is first room name, and now we will get a printout of the first room name is the living room. Accessing subscripts of an optional type. If a subscript returns a value of optional type, such as a key subscript of Swift's dictionary type, place a question mark after the subscript's closing bracket to chain on its optional return value. So here we have our test scores, Dave and Bev's test scores, and it's an optional, Dave's test scores are optional, and so we will put the question mark after test scores Dave, and then we'll put a 0. If it exists, great. We're going to set the 0 test score to 91 here, and then the 0 test score for Bev to append 1 to it. And then for Brian, Now, Brian's not in the array, so it's optional. So Brian will be nil, so that 72 doesn't matter. Now, this example, okay, we just talked through it. Just repeating itself. Linking multiple levels of chaining. You can link together multiple levels of optional chaining to drill down to properties, methods, and subscripts deeper within the model. However, multiple levels of optional chaining do not add more levels of optionality to the return value. So if one is nil, then you're just going to have nil. So for example here, John.residence doesn't exist, then .address question mark .street question mark, it's all nil. Okay. And then if it's there, if it's set, any of these failing to nil as we go deeper will cause the whole thing to just become nil. And now chaining on methods with optional return values. The previous example shows how to retrieve the values of a property of optional type through optional chaining. You can also use optional chaining to call a method that returns a value of optional type and to chain that method's return value if needed. The example below calls the address class building identifier method through optional chaining. This method returns a value of type string as described above. The ultimate return type of this method call after optional chaining is also an string optional, or an optional string. If let building identifier equal John.residence optional, .address optional, .building identifier, print John's building identifier is building identifier. If you want to perform further optional chaining on this method's return value, place the optional chaining question mark after the method's parentheses. And here you can see .building identifier parentheses, and then you can see its optional return value, and then we're seeing if it has the prefix the, and if it begins with the, then we'll print something, and then if it doesn't, we'll print some failure case. And in the example above, you place the optional chaining question mark after the parentheses because the optional value you're chaining is the method's return value and not the method itself. And that's it for optional chaining.